Hello again. This video we're going to cover some basic logic in Excel. So we're going to start learning about the if function and maybe some related functions that do logical operations. So go ahead and find that if function sheet. So if is a really powerful thing in Excel. It lets you do really any kind of like logical check where you start with some condition, you check if it's true or false. If it's true, you do one thing. If it's false, you do another. And it sounds really simple, but it's really powerful. And that's kind of how, if you've been using this spreadsheet already and it pops up and says good or it says try again, that's just like a series of if statements that are checking if you've gotten the example right. So it's being used everywhere in here and other sheets. So let's go ahead and learn about it. So in Excel, the if function syntax is right here. So it takes three arguments in its base form. The first argument is the condition you want to check. So that's something, and it has to be either true or false. It can't be a number. It can't be a string of letters. It just has to be either true or false, and Excel will know what to do with that. And then the second argument is the output if it's true. The third argument is the output if it's false. And so what your cell looks like afterwards is going to depend on that condition and what you've put in for those outputs. So let's do some examples here. Let's say you wanted to see if students failed or passed a class, really simply. And so we can see here, like this, there already was an attempt at putting an if statement in here using that syntax, but it's a little bit messed up because we want it to say either passed or failed so that it's easy to just know what's going on. And right now it says false for some of them instead of failed, whereas some of them passed. So to fix that cell, we're going to go ahead and oops, click into here and go up to the top. You can see we have a condition to check. So is the cell to my left greater than or equal to 60? So say that's a passing grade needs to be at least a 60. That's what that's saying. If it's true, print out passed, and the quotes make it a string so we can have letters instead of numbers. And then what we're missing is this third argument of the value if false. You can see Excel's showing, hey, there could be a third argument here. And so by default, it's just saying false, and that's why you see that there. But instead, we could put a comma at the end, and now you can see it's bold in this third value of false argument. And I can put it in quotes and type out pass, or sorry, not passed, passed is the other one, failed, and end the quotes. If I hit enter here, now suddenly this one says failed because their grade was 50 is less than 60. And since the value is my cell greater than or equal to 60, that's not true because it's less, then it's going to print out failed, that third argument. And I can go ahead and get that to apply to the others by just dragging it down. Now we can see the past ones stayed the same because those were already correct, but the false ones have switched to failed. So that's an example of how you might use this and kind of giving you that syntax. The next one here, you have to kind of write it yourself. And so this is bringing back our budget example from before. Say you've done your budget calculations, you've added up your total, and you just want to quickly glance and say, am I over or under budget? And so what we could do is have an if statement that prints out still good if it's less than your budget and over budget if it's more. So I need an equals. I'll type out my if and open it up. So first argument, logical test. We want to check if the total, this cell, is let's say greater than the budget, which is this cell. If that's true, if my total is more than my budget, then I must be over budget, right? I've spent more than I wanted to. And I put that in quotes. Okay, comma, third argument. If that check is false, so if the amount I've spent is less than my budget, then I'm still good. So I can type out still good and close it off. And there we go. This one, sanity check, we can look and see this total was 180. My budget was 250, so I should be under budget, and there it says still good. That's great. And so if I just drag this over, it'll autofill. Great, some of these are still good, some are over budget. Over budget, 282 is more than 240, so that makes sense. We can kind of see, again, that autofill moved my relative cells over so that it's looking at the right column. So that works great. We could have flipped it and said, check if it's less than, but it doesn't matter. So for this to work, if statements need some kind of logical operator, like to check a true or false, right? Because if I had just put just 180, like look at that, it wouldn't know what to do with that. I have to give it this like greater than thing that says, okay, is this true or false that it's greater than that? So our options for that often are things like an equal sign to check if it's equals, a less than, a greater than. You can combine them with by doing both. You can do like a less than equals to, a greater than equals to, and things like that. So this example is going to give us a slightly more complicated thing. So let's see if we can check if we've won or lost a sports game, right? So we can do equals if and compare the scores. Our score, if it is greater than their score, then if that's true, if our score is bigger than theirs, then we've won. So print out won. If that's false, then we have lost. Print out lost. And I'll close that. Enter. Okay, this game we've won 67 to 43. Makes sense. I can double click this and go down. We've got a bunch of won lost, but wait a second. Some of these are wrong, right? Because we've tied a couple. There's another option here. 61 to 61 is a tie. And we just said that we lost because, well, our score wasn't bigger than theirs. And we didn't check if it was equal. So how are we going to do that? That brings us to nested if statements. So we've learned about an if statement. Let's say that we know how to do that. The other thing you can do is just start combining them and building more and more and more if statements as much as you want, right? Because the entry to an if statement doesn't need to just be a string, won or lost. It could be another if statement that it checks, and you can just nest conditions. So let's look at a little, for this sports example. At the start, we check if our score is bigger than theirs. If that's true, then we win, done. If that is false, there's still two options left. One is that our score is less than theirs, which means that we lose. And the other is that our score is equal to theirs, or just our score is neither greater than nor less than theirs. And then we must have tied. So we could go up here, and there's sort of an example showing you what I'm about to write out right there. If we update this and say, okay, if our score is bigger than theirs, we won. If that's not true, we can't just say lost because there's still two options. So we need another if statement here. If our score, F97, is less than their score, G97, then we've lost. So for sure, if our score is lower, we lose. And then finally, if this is false, I'm going to say tie. And why does that work? So if this condition, our score less than them, is false, we must have tied, because in order to get to this point, we've already checked if our score is bigger than theirs. And so what is happening in this one is that both our score is not bigger than theirs and our score is not less than theirs. So it must be the same. Okay, so if we drag that down and look at that, we have ties on the ties and all the others are won and lost still. So that's a nested if statement. Another example of that is, say you're checking the state of water. We can say if the temperature in Celsius, oops, I don't have an equals. See, when I clicked it, it got confused. I need equals if temperature in Celsius is less than 0. Then I must be a quote solid. Right? That means we have ice. If that's not true, then I need to check again. If the temperature, B158, is greater than 100, then I'm a gas or steam. And if neither of these are true, which is this last value, then I'm a solid because I'm in between 0 and 100. Oh, sorry, not a solid, a liquid. We just have regular water. Sheesh. Okay, so we got solid for -20. That makes sense. Drag this down. We've got a bunch of liquid in the middle and then gas when we go over 100. Looks great. So what if we want to check multiple criteria at once? We've just shown you how to do, like you have 3 different things you're looking at with 2 if statements, but you might have more. What if you had like 10 different criteria you wanted to check all at once? And writing like 9 if statements for that could get a little bit annoying. But sometimes there's a way to simplify it, right? There's these other functions, and, or, and not. And what they do is check many things at once. So an and statement will check if all of a series of criteria are true, then it will print out true. Otherwise, it will print out false. So your and is always giving just a true or false as an output. And so this is something you would put in that first argument of an if statement to then do something with, right? It prints out a true false that we can use to then execute an action. And so again, and is if everything we put in is true. So one thing we could do is say you're like a material scientist and you want to check if we have low thermal expansion and high thermal conductivity. We're not going to get into really what that means. This is a material science class. But let's say someone gave you this and said, look, I checked if these meet the criteria each individually, but I want you to check if it meets them both together so we can do that final selection. So your job is just to check if both of these columns here say that it passes, right? And if so, then we're good. If either of them fails, then we're in trouble. So an and statement, I'll start by just showing you what and does, and then we'll fix it to print out a pass or fail. So if I just type and open it up, I can check these 2 guys next to me, and oops, we got confused because these are just saying fail and pass. And doesn't know what to do with that, right? That's not a true false. And only takes in true false, it only puts out true false. It doesn't know what to do with a string that says fail, even though we as humans maybe know that that means, okay, well, if a fail is the same thing as false. But so let's say if this is equal to, I can take the whole thing actually. If this is equal to pass, then we're good to go. And see, this says false, right? So I said if all of these arguments here are equal to pass, then I'm true. If any of them is not, then I'm false. Okay, so these are both fail and it says false. That makes sense. But if I drag it down, okay, we have a bunch of falses and trues and falses. Great. So the 2 that have pass here are true. That's good. This one has like a pass fail and it was false. Okay, so and is checking if both are pass for us. But we don't want it to just say true false. We want it to also say pass fail. So this function that I have here is going to become an argument of my if statement. So I'll go back to the beginning. I'll write out my if. This is my first argument. When my and is true, then I say pass. When my and is false, I say fail. And you can see this is just going to transform those true falses into pass fails. And there we go. These ones pass, other ones fail. Excellent. Another similar function is the or function, which does the opposite of an and. So and was checking if all of the conditions are true. Or will check if any single one of the conditions are true, then true. If all of them are false, then false. So this example here is if you want to take Calculus 1 at GTCC, you need to pass, there's different conditions that you could do to meet that. So you need either a high enough SAT score, a high enough AP score, or a high enough score on the AccuPlacer exam. So my or statement equals or. And again, I'm just going to do it first as an or statement, and then I'll add the if around it so that we see what's going on. And I can say, okay, what's my first condition? SAT score needs to be greater than or equal to, so you can see my greater equals, just gonna do that, 600. AP score greater than or equal to, 2. And then the AccuPlacer score greater than or equal to 90. Okay. So it just says true. So what's going on? Let's see. The SAT score was not high enough. The AccuPlacer score was not high enough, but the AP Calculus 6 score was high enough, right? A 2 is greater than or equal to 2. And so we got true. I drag this down. We have a bunch of true, false, but that's not helpful. What I really want is to put that inside of an if statement and say, if any of these are true, then you're ready. Yeah, ready. If all of them are false, then not ready. Okay, and now my true falses will become readies and not readies. And so that's how you would kind of combine an or statement with an if statement to show if something is show what's going on. There's one more Boolean function to do here, the not. So not is a little bit different from the and or. It doesn't check multiple things at one time. All it does is flip a criteria. So if something is true, it will print out false, something false will print out true. Just give you the opposite. And that's kind of can be useful. Say you like made a mistake or you did something where you just want to switch a condition, you don't want to figure out how to rewrite the whole condition from scratch. So let's say here we have this table that's checking if these beams are fitting the specs. So down here are the specs that we have, and then down here are the beams and their stats. And over here, this checker, whoa, look at that, a bunch of logic, a bunch of ands and ifs to tell me if we're meeting these requirements. So let's check and see. All of them are failing right now, so something's probably wrong. Let's go ahead and fix this. So we can go one by one and look. B226, so the blue is length. The length should be between 430 and 590. If that's the case, it should be true. Okay, so that one is inside that. My other check, sorry, it needs to be greater than 430, less than 590. Okay. Let's say greater than 590. Yeah, so greater than 430 and greater than 590. So that's probably wrong. We want you to be less than 590. I'm going to go ahead and put a not there. Let's see what happens there. Oh, now we pass. See, look, before, I can go down to this bottom one, we wrote this wrong. So we were checking if it was greater than 430 feet and greater than 590 feet. That's kind of pointless, right? We wanted to check if it's in between. So if I go ahead and copy that not down to all of them, then suddenly they all pass. Oh, actually, it turns out these are all good. We just screwed up one of our criteria. So that's going to make our beam design choice a lot easier. Okay, so here's a little game to practice these. Oops. Sometimes these boxes are just not big enough to fit the text. Okay, let's try them out. Look at the statements on each line and choose a function that would print out true based on those statements. So what's going on here? If you click on this little question mark, a drop-down box will appear with possible choices. So you could do and or not. I see. So this game is saying, look at these statements and pick which of these we want in order to make it true. So statement one, roses are red. Statement two, violets are blue. If both of these get added together, then we'll get true because those are both true, right? Roses are red, violets are blue. Chuck Norris has no beard and a blank cell. So what are we going to do here? Well, an or no isn't going to get us there. An and isn't going to get us there. What's going to get us there? We just have the one option. Chuck Norris has no beard. Well, Chuck Norris has a beard. So not is going to give us true. Star Wars prequels are better than the originals. Obviously not true. Michael Bay loves explosions. Obviously true. So let's do an or and just pick up, okay, the Michael Bay one gets us there on its own. So you can see this is just kind of a practice of how to use these. I'll let you finish them on your own. So moving on from this little statement game, there's another example here that's kind of like a complicated game of what a bank like fee stuff might do, a bunch of logic that goes together to say what your fee is going to be, if it should be waived, if you're a student. Okay, trying again. So my video just cut out on me. there. I was just closing out. We were going to say that this example here is kind of like a harder than anything you would actually have to do option of sort of combining all the logic and trying it out. So you can work on that if you like. I don't want to spend a bunch of time going over it. So I'm just going to stop here and I'll see you next time.